The best news is that we have a realistic chance of reaching this planet in the near future, which means we could potentially be on the verge of making contact with an alien world for the first time. Researchers believe that there is a second, Earth in the Alpha Centauri star system. It is a rocky planet that is slightly larger than Earth and may be located in the habitable zone of Proxima Centauri. As early as the 19th century, our forefathers believed that Alpha Centauri was a single star. However, it was later discovered that Alpha Centauri is actually a twin star system made up of Alpha Centauri A and Alpha Centauri B. The third companion, Ed, was found in 1915 by the Scottish astronomer Robert Innes. Based on his calculations, the Proxima Centauri system must be our closest cosmic neighbor. The stars Alpha Centauri B, and Proxima Centauri make up the stellar system, which is located slightly over 4 light-years away. One intriguing category is the Proxima Centauri system. People were shocked to learn that these 3 stars are the closest to Earth despite their low brightness because Proxima Centauri is a red dwarf star, and Alpha Centauri A and B are a double system made up of a yellow and an orange DWDF star. However, these stars are far from being the brightest in the night sky. The Proxima Centauri is now the subject of several observations and investigations. The optical interferometer on the Very Big Telescope allowed for the direct measurement of the Proxima Centauri's angular diameter, which was found to be 1.02000 of a second of arc, resulted in an estimated diameter of just over 200,000 kilometers, which is roughly 17th the diameter of the Sun, and only 1.5 times that of Jupiter, but 15 times that of Earth. However, the discovery of numerous exoplanets, rather than the incredibly accurate properties of the stars, was what made this system truly remarkable. Who would have guessed that there could be other planets so near Earth that resemble our own planet? Earth 2. 0 in the Proxima Centauri system. The most intriguing of the 3 stars is Proxima Centauri, which is also the faintest. The orbits of Alpha and Beta Centauri are extremely close to one another and were most likely once a binary system. The Proxima Centauri, on the other hand, seems to be trapped and has a common center of gravity with the other 2. However, it orbits its 2 partners in a wide arc on a strongly eccentric orbit, which occasionally takes the star closer to us before moving away once more. Researchers have inferred the existence of multiple exoplanets in the Proxima Centauri system based on transit observations and orbital irregularities. In 2016, a group of scientists led by G.M. Andada Escode from Queen Mary University of London announced the discovery of the first exoplanet around Proxima Centauri. This planet was named Proxima b, with the aid of the HARP spectrograph at the Lilla Observatory in Chile. Scientists were able to gather additional information about the planet, which was a truly sensational discovery. By closely monitoring the star's radial velocity, scientists were able to determine Proxima b's size, mass, and orbit. The radial velocity method allows us to measure minute variations in the star's velocity and make inferences about the gravitational effects of orbiting planets. According to this, Proxima b has a minimum mass of about 1.27 Earth masses and orbits its star at a distance of about 7.5 million kilometers, or about a 1/12 of the distance between Earth and the Sun. Even though Proxima b is close to its star, the planet is in the habitable zone, meaning that the temperatures could theoretically support liquid water on its surface. The reason the planet is not burning itself on its sun is simply because Proxima b is much fainter than our Sun. Of course, we can only speculate and guess what the climate and seasons might be like on a planet where a year lasts less than 14 Earth days, and we can only imagine the conditions under which any living things would exist there. Proxima b's discovery and designation as an Earth-like planet sparked a flurry of interest in 2016, prompting scientific investigation and conjecture on its habitability and potential for. The excitement around the recently found planet is still being fueled by harbor life. In open research, scientists hypothesized that Proxima b would contain an atmosphere that would permit liquid water to exist on its surface. However, a few months after the initial encouraging information about Proxima b was revealed, something was discovered that put an end to all hopes. In these conditions, scientists believe that the existence of an atmosphere around Proxima Centauri is nearly impossible, and biological life as we know it would most likely not be possible in such a world. Proxima Centauri continued to be a very active red dwarf, and the ejections are fairly frequent in the hopes of finding life on Proxima b. However, the star's outbursts soon gave way to another circumstance that significantly influences the question of whether life exists on Proxima b. Researchers have calculated an intriguing fact in a narrow strip that represents the transition from the day to the night side. A temperate climate could predominate even on a world like Proxima b, and life would be possible there on a voyage of discovery in the Proxima system. The planet most likely orbits its star in a bound orbit similar to our Moon, with one side facing away and the other side always facing the star. This means that the day side of the planet is always bright and warm, while the night side is dark and cold. For decades, the Proxima Centauri system has captivated academics. Experts and amateur astronomers alike have been fascinated by the notion that a rich planetary system like ours is nearby. In 2020, scientists discovered evidence of a second planet in the Optimus Centauri system called Proxima c. Proxima c's existence was likewise speculation based on remarkable radial velocity measurement data. Although Proxima c is located far outside of the habitable zone and has an estimated mass of 7 Earth masses and an orbital period of around 5 years, scientists have warned repeatedly that we must avoid the error of extrapolating the parameters of our own world to other systems. Even our own Earth surprises us time and time again when we discover strange life forms deep in caves in freezing cold and complete darkness under kilometers of thick ice in the Antarctic. Researchers have discovered entire biosystems and in the most toxic and boiling hot thermal environments. Astrobiologists also frequently caution against judging even life by earthly standards because we do not know whether habitable worlds in other systems look completely different from ours and whether there are life forms that can cope excellently with darkness, cold, or radiation. Unicellular creatures that have properly adapted to these harsh circumstances have been discovered in the waters surrounding volcanoes. It's both startling and intriguing to consider that life could exist in similar circumstances on other worlds. What do you think? For a while, radial velocity data offered more proof that there were planets in the Proxima system. We have been waiting for the James Webb Space Telescope to investigate the Proxima system and confirm or deny the findings for years after Proxima d and d were categorized as gas giants. However, researchers withdrew the data for the time being after discovering mistakes in the measuring techniques. Researchers continue to see an almost limitless reservoir for future missions and research here. So, if we are able to send probes to alien stars, this system would undoubtedly be our first target. What have we missed about the Proxima Centauri system? Our neighboring system has not lost its interest or excitement for exoplanet research. With a mass of roughly 12.3% of the Sun's mass, Proxima Centauri is extremely massive for a star of this size. Its average density, which has been determined to be 57 G per cubic cm, is far higher than the Sun's normal density of 1.4 G per cubic cm. Proxima Centauri's overall brightness is barely 17% of the Sun's, with more than 85% of its energy coming from infrared wavelengths. The Proxima system's conditions differ greatly from our own, as demonstrated by these new measurement data alone, making it challenging to draw conclusions about potential life conditions and planetary changes. Therefore, the conditions on Proxima b, which is about 7.5 million kilometers from its star, may differ greatly from our expectations. The impact of a star that mostly emits infrared light on neighboring planets can differ significantly from that of a star that emits light at more aggressive frequencies. Strong radiation bursts and coronal mass ejections that have a major impact on the system's space weather may not be as harmful as we initially believed. One man in particular has been inspired by the findings of a recent study to maintain his faith in the potential habitability of the worlds in the Proxima system. Multi-billionaire Yuri Milner is the driving force behind the SETI program, which scientists use to look for evidence of extraterrestrial life in space. Milner is adamant that before we can make a judgment on sending nano spacecraft to Proxima b, we must first observe what is actually happening in the Proxima system. These nano spaceships could reach the Proxima system in just over 4 years. These tiny scouts would then fly around the Proxima system for a few years and provide us with images from there for the first time. Imagine what it would be like to get the first real images of the surface of Proxima b, or to witness firsthand how a star from this special class shines thanks to the breakthrough star shot. It sounds too unbelievable to be true, but many spaceships, equipped with cameras, are to be accelerated to nearly the speed of light using a brand new technology. The Yuri Milner-funded mission aims to launch a fleet of about 1,000 small probes. The high density is meant to ensure that some reach the Proxima system when others fail. If all 1,000 probes arrive, we would receive data from every possible angle of our neighboring system. All of this should be feasible in the 2030s. Laser beams from the ground accelerate the spacecraft, which are only a few centimeters in size. With this initial speed, the mini-probes would be accelerated further and further, at least that is the plan. Hundreds of scientists are currently working on the project's implementation in laboratories and scientific centers in the USA, while others are awaiting the most recent measurements from the James Webb Telescope in the Proxima system. Another exciting prospect is the brand-new 35-meter telescope, which will start operations in the Chilean Andes toward the end of the decade. The performance of this facility should be able to surpass even the Webb and set entirely new standards, particularly in the search for exoplanets. Subscribe now to ensure you never miss another video.